of the National Estuarine Research Reserve System, which consists of a coastal network of sites, 29 sites across the US, with the mission of protecting estuaries through scientific research, stewardship, education, and training. My name is Vanessa Dornish, and I'm the Coastal Training Program Coordinator at the Reserve. So my role is to provide training and outreach for coastal decision makers with a focus on increasing the resilience of both our built and ecological communities. And so to that end, our goal of our webinar today is to inspire coastal managers to make more resilient management decisions by sharing how coastal monitoring data can be collected, analyzed, and used to inform decisions that support long-term adaptation and resilience to coastal change. We have two fabulous speakers this afternoon. First, we'll hear from Dr. Norbert Psuty. He's a professor emeritus at Rutgers Department of Marine and Coastal Sciences, and he's also affiliated with the Jacques Cousteau Reserve. And he'll talk to us about why monitoring is important to understand coastal change, and also his data collection and analysis methods at Sandy Hook. We'll then hear from Pete McCarthy. He's the Sandy Hook Unit Manager at Gateway National Recreation Area. He's going to talk to us about management at Sandy Hook and share examples of how he's been making resilient management decisions for the park with the help of monitoring data. Couple of Zoom logistics. I just want to make everyone aware that we are recording this session today so that it can be shared with those who can't be here. Each of our speakers will talk for about 20 minutes, followed by an audience question and answer period. You're welcome to put your questions in the Zoom chat at any time while they're speaking, and I will field them to the speakers after their presentations. Or if you want to wait until they're finished presenting, you can come off mute during the question and answer period and ask your question yourself. And so with that, I am going to turn it over to Norb. Norb, I'm going to stop sharing my screen, so now you should be able to share yours.
Okay.
Very good, we see it.
All right. Welcome, everybody. My name is Norbert Psuty. As Vanessa said, I'm associated with Rutgers and with the Jacques Cousteau Reserve. And I'm going to report to you on procedures that we are following in a variety of places up and down the coast in order to kind of gather information about the changes that are occurring. And I'm going to be describing protocols, procedures for doing things in a systematic and reputable way. Why isn't it? It's not shifting to the next slide.
Do you have two screens or one screen, Norb?
One screen.
If you go down to the bottom, hover over it, it looks like there's an arrow down there.
Oh, yes.
That way?
Yeah. Yes, okay, I used the arrow, I guess. All right, basically what we're doing is tracking the changes that are taking place along the coast. And the coast is basically the beaches, the dunes, the shoreline, the features that are found here. And we're trying to develop a series of metrics, a series of measurements, so that we can make comparisons and come up with the dimensions of change. One of the important drivers for change along the coast is sea level rise. And that consists of a variety of things. Basically, it is the water that's being added to the world's oceans in the form of melting of snow and ice, but it also involves the depression of the land. That we, for example, along coastal New Jersey, we were on the subsiding coast of the North American continent. And this graph we have over here is taken from the tidal gauge at Sandy Hook, and it says that from the early 1930s to 2020, we have a consistent elevation of water level recorded by this gauge, and it says relative sea level trend. Relative means it's the combination of the water coming up and the land going down, and together this is on the order of about a little over 4 millimeters per year, or on an on a century basis, it's a little over 16 inches. For that time period, water has come up, it's inundated the landscape. We find that the rate of change is described in this case as a linear rate of change, just sort of connecting all the points. But there's also a nonlinear or exponential rate of change. People who have studied the statistics associated with this information say that as well as just showing the straight line, there is an equal explanation which actually has an increasing rate of change through this time period. And actually that makes a big difference in the longer term, because it really means that the rate of inundation is actually increasing per unit time. If we talk about 16 inches per year at a century level with this linear rate, we find when we apply the exponential rate, it's somewhere on the order of 24 inches. Now that's a big difference in the coastal zone in terms of the inundation. And some of the explanations, or some of the experts who look at this say it's even faster than that. There is a really good chance that's going to be twice that amount. And so there is in fact changes occurring, being driven by this one thing, sea level rise, which essentially has two different impacts. One is a kind of drowning of the shoreline, drowning of the features that are present along the coast, but it also is exposing the coastal area, because now storms are able to reach farther inland because they're starting at higher water levels. So a sandy storm in a couple of decades would actually reach even farther inland than it did during the time when it occurred in 2012. So basically, sea level rise is a major driver, which is inundating our coast and causing changes both in terms of the flooding and also causing exposure changes through time. Another important variable is the sediment budget. We talk about negative sediment budget, meaning that there is more sand being lost from our coastal zone than is coming into the coastal zone. So there is a net deficit, a net negative change. And as you look at this picture of coastal New Jersey, you can see that there are no major streams draining the continent that are bringing quantities of sediment to the shoreline. Most of the streams are discharging into bays and estuaries, and they haven't filled those. So sediments are not getting to the coast. Even though there is some material coming from the continent, it's not reaching the coast. There is some sediment that is being redistributed along our coast. That, for example, alongshore currents in Monmouth County tend to be toward the north, and sediment is being eroded along most of the coast and is being transported to the north to add to Sandy Hook, or at least portions of Sandy Hook. To the south of Monmouth County, sediment is being transported primarily to the south to add to the barrier islands and barrier spits there. Because the transport tends to be from north to south along the rest of the coast, we find that many of these islands are extending at their southern margin, but are actually eroding at the northern margin. So that is another kind of redistribution that's occurring associated along our coast. There is some retention of sediment in the form of tidal deltas at major inlets or estuary mouths, and that is a kind of saving of sediment until the shoreline gets to that position, or is basically enough material collects to emerge above water level. In addition, there is human manipulation affecting the sediment distribution. Humans have erected barriers, groins, jetties, bulkheads, and these are affecting the distribution. In addition, humans have been going after some available sediment and dredging material, dredging from the offshore, putting it on the beach in the form of beach nourishment, dredging it from places in the bay and putting it on the beach. But that's human manipulation That's short term, normally only good for about 4 or 5 years. And then that quantity is used up and you're back to a negative situation once again. So basically, we have two very important drivers occurring along our coast. And this isn't just our coast, it's basically about 90% of the world's sandy shorelines are doing the same thing. They're essentially eroding, being redistributed, and being repositioned as the -7 budget and sea level rise affects the distribution and location of the materials. So two major drivers, -7 budget and sea level rise. Now we have to try to get some idea about what's happening. What are the responses to these two drivers? How is that changing our environment? What is the rate at which it is changing? And here's a typical profile, a sandy beach profile, a beach, a dune, offshore beach. And we've had to pick a few places to monitor and see what is happening. We picked things such as like a dune, the crest line of a dune, the dune base. We talk about the berm crest. Essentially the beach has a kind of contact between the upper level and the beach face. The crest is that contact between it. We have another variable that we tend to look at because it tends to be a nice line that we can find, and that's a swash line. You're all familiar with going to the beach and see, oh, there's a wet, dry line. That's a swash line. If we can define that line a little bit better, the neap tide swash line, essentially there are spring tides and neap tides. And if we took the high tide, neap tide swash line, that would be a defined location and something that's repeated on some interim. So basically we have a choice of looking at features or potentially a swash line. I've been working with the National Park Service and Fish and Wildlife and J.C. NERA for the last 20 years or so. We've been working on the development of protocols or procedures to track some of these changes. And we have developed the equivalent of 3 different categories or 3 different protocols for doing tracking of change. We have so-called one-dimensional, a line, and we have developed a report that describes all of the procedures, all of the rationale, all the way in which we can gather that type of information. That's 1D. We have 2D. 2D basically are profiles. Now we're looking at topography, something about the beach, something about the dunes. And there are methods for doing that. And then we have 3D, and 3D is a little bit different because that one is the creation of some elevation models, and that's looking primarily at sediment supply and sediment budget. So we're looking at trying to find out what are the accumulations, how much is it, what are the volumes involved. And so we have these 3 protocols that are listed in the National Park Service IRMA database, and they are available for anybody to go there and download and use. And at the end, Vanessa is going to share with you these sites. The protocols that are described there are currently in use. Each of the places listed here is following the protocol. It's basically a data collecting methodology. Fish and Wildlife Service, National Park Service, the National Estuarine Research Reserves are all doing this in a similar way. And beside the ones that are shown here, there are other National Park Service areas along the Gulf Coast and the Southeast Coast, which are also applying these same protocols. Initially, this started around 2002, and we've been doing this ever since. In the last 2 years, the New York City coastal parks have been added to this. So they are also doing the same kind of data collection. What we're doing for the most part is a development of or tracking the neap tide swash line, the line that you see here, for relatively easy to determine, and we track it with a sub-meter GPS system. Can be either handheld, as our gal is this is Andrea. Andrea's collecting the shoreline position data, the neap tide swash line, or we can mount the same piece of equipment on a vehicle and drive that line. So it collects that position. And we want to do this in a temporal comparison. You can do this almost any time, but we found by essentially a lot of testing that spring is a time when we can sort of get a more consistent position. It is the end of the winter season. It is the end of the erosion, and it's before the summer season and accumulations occur. And so we basically say, okay, let's collect every spring, let's collect every annual spring, and we can make comparisons. We've actually looked at spring, fall, winter, summer. We find that spring and fall are the best times, and of the two, spring tends to be a better time. However, there are some things that are associated with our collection that we have to sort of be aware of. There are some, we call them uncertainties. There's some variation. So for example, the instrument has a sub-meter accuracy. So presumably it's somewhere on the order of 1 to 2 feet accuracy in terms of its location. There is some wave run-up variation, as you can anticipate, that the waves are not the same each and every time period. And so we have to look at, okay, let's look at wave conditions which are similar, or let's look at water levels that are similar. So every time we go out there, we want to say, okay, this is a similar water level than we had in the past, and therefore the line is comparable. We like the high tide elevation line because basically it sticks around for a while for the next high tide. And we like the neap tide, high tide water level. Neap tide, every 2 weeks, we have a lower neap tide. The lower neap tides, the lower high tides tend to be more consistent. So we're looking at reducing variation. So instrument accuracy is a built-in instrument capability. Wave run-up, we're looking at low wave run-ups. Neap tide tends to give us when there is the least amount of tidal variation, and then the operator is to be trained so that their operator follows the same general line each and every time. Together, we find that probably amounts to maybe on the order of 5 meters of variation year to year. I'm sorry, season to season, survey to survey. So there is a kind of I'll call it uncertainty level that's associated with the collection. Now I'm going to give you a few slides here to show you the application of this. We conducted a couple of surveys that were associated before and after a predicted storm, ran the shoreline at Sandy Hook prior to the storm, ran the shoreline at Sandy Hook after the storm, and then we now have to compare the results. What we do is create, and this is something called DSAS, Digital Analysis Survey System. And basically what we have to do is establish a baseline in the area where we're doing our analysis. From the baseline, we create transects from the baseline to the shoreline, and that is intercepting each of these survey lines, and we get a measurement of the distance from the baseline to each of these survey lines. We look at the difference, and the difference is projected here. For example, this is a storm, so we expect erosion, and we put erosion into various categories, and we found that compared to the pre-storm to the post-storm, that here is the distribution of losses, erosion in this particular case associated with the particular storm. But we could do this on another basis, and this is when we do it, for example, all our spring surveys, all our shoreline surveys for on an annual basis, and we can now do that same kind of baseline transect comparisons and show that, all right, here is the distribution from spring 2012 to spring 2013, the distribution of pluses and minuses, the distribution of gains and losses. So everything that's showed as red is in fact a general loss. The deeper the red, the greater the loss. The deeper the blue, the greater the gain. And then we actually incorporate our uncertainty value here. If you look at the legend over there in terms of gains and losses, there's also a sort of a gray area. And we say, okay, look, we're not going to look for those places that are less than 10-meter changes. That's going to be within the range of uncertainty. Actually, it's quite a bit, that's more than the uncertainty, but we're being cautious and say, all right, let's point to the places where we definitely know there are longer term gains and losses. So as you look at the baseline, if you don't see a blue peak or a red peak, it means that it's in the vicinity of the uncertainty level within tens. And for the most part, as we see 5-year net change, most of the shoreline there is either red or blue. There are areas where there is considerable erosion or areas of deposition, and that's our data. That's our data for this time period. And we've been doing this now from about, for our area here, from 2008 to 2020, and we have a huge amount of data showing what's happening along Sandy Hook. That was 1D. Now I'm going to look at 2D. 2D basically is, let's look at the beach. Let's look at the foredunes. Let's look at the position of the beach face, and let's kind of get some measurements in terms of how it's changing. We're going to gather information by means of running profiles. Our instruments we start at benchmarks along Sandy Hook. You see the triangle, that there is a post that's been put into the sediment, and that becomes a starting point. And we go back to that starting point, spring and fall, and we basically collect along a line. The line is established in with a GPS coordinate system, and it basically allows us to go back to that same line and run a profile each time we go out there. We have a slightly different piece of equipment to work with here. The previous instrument we had a sub-meter accuracy. This instrument has an accuracy of on the order of 2 to 4 inches. 2 to 4 inches vertical, 2 to 4 inches along shore spatial. And we have the instrument working off of satellites telling us where we are. The instrument then collects, and what we do, we start at the monument, walk along that transect, and you can't see it well here, but basically the controller, which is mounted on that pole, has a screen, and it says this is where the line is, this is where you are, and you more or less walk along that line. Walking in the grass and everything, you have to sort of punch a button. It's collect a point. Once we get onto the sand, we put it on this device, which is mounted on a bicycle wheel, and push it, and just set it to collect every second. We said, collect a point, and we basically collect a point to create profiles. And here are some profiles that are collected at different springs. And it says, okay, look, here's how the profile has changed through the years. The red line was the original line in 2012. The black line is the line 2017. And the line has shifted. Been shifted inland. The features themselves have moved around. And we have information now that says, okay, here's the profile that's been changing. Here's information we can get them. We've gone to the sites and said, okay, look, this is the location of the beach, and anywhere around 2.4 elevation relative to NAVD 88, which is more or less mean sea level, is the beach area. That's where waves tend to be more active. Everything above that is more dunal. That's where waves are not as important. Maybe that's more storm, that's more wind. And we said, okay, look, here are the changes. Here's on our profile. Here's the cross-section area at these various times. And is the cross-section area getting larger, getting smaller? What is happening here? That's information that we're gathering from our profiles. We also can look at what are the dimensional displacements. How has the intercept of NAVD 88 at the beach face changed? How was the intercept of the dune toe change? How would the dune crest change? All that's available on our profiles, and we'll have that for all the profiles we've established for the area in question. In the 3D, which remember we have 1D, 2D, and 3D, areas of special interest. This is a little bit different. This is a little bit more details, more information. Now, instead of having a single profile, we take multiple transects in this area of special interest. And we basically use the data that are collected along each of these transects to create a digital elevation model. And we can now interpret from this digital elevation model, we can interpret where the location is of the intercept of the mean sea level. So we have a shoreline. We can look at where the beach is, where are the dunes, where are the features of the dunes. We can identify the presence, the distribution, the area that is composed of beach, dune, whatever. That's present on our digital elevation model. And we can also determine where the gains and losses are in terms of volumes for any time period. And this is sediment volumes. How much material is being collected? How much material is being lost? What are the things that are being exposed as a result of these changes? Now that's what we've been doing. We essentially go out spring and fall. We gather via our instrumentation. We gather locations of shoreline positions. We gather locations of the dune forms. We gather locations of the beach widths, the shoreline positions. We gather information about the quantity of sand that's being either gained or lost in this area. And these are all based upon the GPS systems that have been in place now for over a decade. And it's important to realize that this is being done at all those places identified up and down the coast at the same time, using the same equipment, producing the same information. Because comparable, we see what is happening up and down the coast. And that's important to us to know then how things are being exposed, how things are being protected, and what is occurring. And it's all resulting in a variety of reports. So our objectives, essentially to identify and quantify these changes, these trends, to look at the conditions that are changing and the causes of the conditions. And we are providing information to management. We're trying to allow management to evaluate what is occurring and what are potential outcomes of applying management strategies. So that's my presentation. It basically is monitoring program in place based upon a long-term record of evaluating the type of equipment, the procedures, the methodologies, and the outcomes. Thank you.
Thank
Vanessa,
you.
all yours.
Thank you, Norm. Thanks. That was super interesting. I definitely much better understand the 1D, 2D, 3D protocol now than I did before. So thank you. And hopefully everyone else was enlightened as well. We do have one question in the chat from Judith. She's asking what we should do about the fact that sea level rise is driving erosion of our beaches. And do you think that continued beach renourishment is a good solution? And I'll say, I know that's that's a huge question. In the interest of time, Norb, maybe give us the 1 minute abridged version of your answer to that question.
Sure. Okay. Again, beach nourishment is limited, as I mentioned. That it's a couple year, and you have to find the sediments. And there are approved places, but even we're exhausting some of those locations. I think long term, that's not going to be the best solution to sort of preserve what we want at the coast. If in fact you're looking at a kind of retention of the ecological system, you're going to have to allow the systems to essentially function in a different location. You'll have to allow them to adapt and essentially move a little bit. It's trying to maintain it in place is just not to survive. It's not to survive the inundation. It's not going to survive the drowning. It's beach nourishment, short term, giving us some breathing room, but it's not going to be the long-term solution.
Thank you, Norb. All right, with that, we will shift over to Pete to tell us how they have used some of this monitoring data at Sandy Hook to make their management decisions.
Good afternoon, folks. My name is Pete McCarthy. I'm the unit manager here at Sandy Hook. I've worked for the National Park Service at Gateway National Recreation Area for about 23 years. I started off at Jamaica Bay, at the Jamaica Bay unit, worked many years there, and then I've been here at Sandy Hook since 2009. What I'm going to do is talk a little bit about what the practical applications of this of coastal monitoring for us were. And probably the best example that I can use is the experience that we had over the past 9 years in recovering from Hurricane Sandy and where we were going next. So I'm going to talk a little bit of background here. Norb mentioned it before, but I'll mention it again. National Park Service has worked at least 20 years now with Rutgers University and with a consortium called the Northeast Coastal Barrier Network to make informed decisions about what they're doing in coastal resources. The data collection has helped us, has informed us on resource protection, infrastructure, and capital investment strategies. So what does that mean?
Pete, I'm going to sorry to interrupt you. We aren't seeing your screen.
Oh, that's not good. Let's try it now.
There we go. Perfect. Thanks.
All right. Much better. Good. So as I said, we've worked with the Coastal Barrier Network over as well as with Rutgers over the past 20 years, as Norbert mentioned before. And what we were doing is we were trying to inform our decisions on things like resource protection, infrastructure, and capital investment strategies. So what does that mean? Well, resource protection is obviously how we're going to work around the beach, placement of dunes, if we're going to manipulate and put those dunes in, and which we have in certain recreational beaches, how we're dealing with infrastructure along the shoreline, which is basically, if you look at Sandy Hook, we have a number of functions that go along with trying to operate a park for 2.4 million people on an annual basis. And then last but not least is capital investment strategies. The National Park Service, as it invests into its infrastructure, has really looked at how they're doing it. What are they going to invest in? What are they going to stay with? What are they going to let go? In 2014, Gateway had redone their what they call their general management plan. And that plan is basically a map forward of how you're going to use the park or how you're going to present the park to the public. Part of that was talking about what we would do with some of our infrastructure, and it included, what resources do you put money into and what don't you put money into. And it was a little bit controversial at the time. However, we found that, this has been the best way for us to move forward. There were just infrastructure issues that we had and some resources that we just were impractical for us to work with or to try to do any more with. So as we move forward, there's two storms that I want to bring up and talk about a little bit. The first one was Hurricane Irene. Irene had done not necessarily tremendous amount of infrastructure damage to Sandy Hook. We had a bit of flooding. However, there was a heavy duty push on erosion that we hadn't particularly seen as heavy before. You can go back to 1992, and we had issues at areas of Sandy Hook along the coastline that necessitated things like a revetment wall that was put up in an area called the critical zone, and eventually we had experimented with a sand slurry pipeline, which we have in place for sediment transport, which actually Dr. Psuty was a very big player in when it was being developed. However, we've been lucky. It was kind of like having a large weapon that you haven't had to use. We've been blessed with the sediment transport coming north has actually been quite a blessing to Sandy Hook in a lot of ways. The critical zone area where we were actually very, very, very concerned that, one day there could be a breach has really kind of settled in. And a lot of that is due to sediment transport, and most of that sediment transport, and Norb, you can correct me on this, is from the beach replenishment down south. So, one of the things that we've been extremely lucky with is that the folks in Seabright and the folks in Monmouth Beach and Long Branch, they're getting their replenishment, but it's also assisting us up here at Sandy Hook to a degree, even though the cycle seems to be continuous. Some of the other sediment that transports, it continues up not only in that critical zone area, but it also goes further north. We have two areas, and we'll talk about how the beach buildup or the sediment transport in those areas kind of guided us in a direction of repairs. But we get a large amount of sediment transport in an area called Gunnison Beach, which has grown extremely wide over the past 20 years, to the point that when we were trying to decide where the slurry was going to come from, we actually were going to use the beach off we were going to replenish off of Gunnison Beach and move it about 4 miles south into that critical zone area. As I said, though, Hurricane Irene, not too bad. A little bit of erosion, and then eventually we went through a winter cycle, so that kind of made it a little bit chancy, but that following spring, we ended up doing okay. The following October, not so much. Hurricane Sandy. Hurricane Sandy, as we all know, in New Jersey, beat up the coastline. Sandy Hook took the brunt of northern Monmouth County, although if you went up and down, you could see that there were areas that were just completely washed out, devastated. Most folks, kind of looked, and the infrastructure where there was residential was a little different. Up here at Sandy Hook, we had quite a different experience. We were forced to close for about 6 months. Day of the storm, we had tides that just went wild, and at a certain point we were somewhere around in excess of 13 feet above mean high tide at the Coast Guard. Just to give you an idea of how forceful the tides were. The park was closed for 6 months. We lost infrastructure. We didn't have electric up here for probably about 3 or 4 months. We had to wait about 4 months before we even thought about opening up and doing anything with water. We had repairs that were just crazy in regards to trying to get our water lines back in and moving. Dunes that we had on recreational beaches were completely washed out and actually transported into the beach centers that sat behind them. And we ran into issues there. Our entire northern maintenance complex was flooded out and we were forced to abandon that. Again, I talked about the flood tide there and what happened. Sandy Hook had more than $40 million worth of damage. And we had to rebuild within that time. And one of the things was obviously we knew that climate change was going to be a driver of this entire thing. So what do? You come up with a solution that you look at flooding projections, you look at sea level rise, that coastal monitoring gives us those results, and you try to come up with the best way to move forward. On the northern portion of the Hook, where the beaches were the widest, we looked at resilient repairs on the beach, in the beach centers themselves. To the left is the Beach Plaza at North Beach, where we used to have a concession area. We left the building in place where we added some resilient features such as floodgates or flood vents within the buildings, and you can see them. You can see going across where those white windows are, and the picture on the left where those gates are or where those vents are. And over on the right is Gunnison Beach, where it's very wide, and we actually added vents into that building. We kind of changed our philosophy about using concessionaires within the buildings, and we actually use trucks within those areas now, and we have elevated hookups for those trucks, but we will eventually go and we will lease those buildings out. It's kind of been a slow recovery to a degree as we're trying to do things right. Adaptive use. As you went further south, we were forced to go with something that we phrased as adaptive use. So where we had a concession at Area E, a large one, we actually, the building was completely destroyed. We took what was left, and that's the picture on your left, the aerial on your left, and we actually removed the building. We put hookups in for, and if you look to the right, we put hookups in for food trucks, and then kind of left the plaza in place to ensure that we still had an area for people to go and congregate. These were they were on the coast there. Adaptive use further on, we used some old buildings to replace our maintenance facility. The building to your left was a plumbing shop, which sat on an elevation high enough, and I can't give you that figure off the top of my head, that we were able to use that area. And then to the right is our new equipment shop, which we actually had built from new. It was a new facility, and we built it up about 9 feet up off of the ground. That's up on cement pilings in order to compensate for the floodplain in that area, because it was in an area that we wanted to use for this purpose, but we also felt we needed to build resiliently in that particular area. The next piece is actually our sewage treatment plant. If you look to the left, this the picture on the left is pre-2000, 2012. And it was sitting a little bit low. That was actually built in the 1980s and 90s in order to compensate for our leasing program. However, we ran into problems where the projections kind of changed over time. And this actually sits behind Gunnison Beach. And we had an interaction of ocean and bay flooding that came about. And if you look at the center picture, and I don't know how clear you can see that, but that's actually still floodwaters a month after Sandy. That was taken in late November of 2012. And that's still water on the main roads behind the sewage treatment plant. We were able to get that up the following summer with a little bit of luck, but again, we limped along for a bit. Eventually, we built a new sewage treatment plant on the right-hand side using some old parts from the former plant. However, we rose the level of where we did the processing to keep it out of the floodplain. And it actually expanded the capacity out. We had some interesting problems though in the beginning with capacity. Just as a sideline, one of the unique things that we ran into was that the engineers at first didn't recognize that they needed to have the pipes coming in through the processing plant at a certain diameter, and we kind of had the giant stadium effect one weekend where we had a little bit of a backup because we had too many people using the restrooms at the same time. We were able to amend that very quickly, but it was one of those things that, until you run into the issue, you don't really get an opportunity to test it. Other philosophies, or at least methods. Here was what was called the former Seagull's Nest. For those who came to Sandy Hook over the years, the Seagull's Nest was a restaurant and a bar, very popular with the folks coming into the park. And what happened during Sandy was it more or less caught water from both the bay side and the ocean side because of its proximity to the bay and the ocean. And the building itself was essentially destroyed. It took us a number of years. We had to raise it. And the idea was because of its location, we wouldn't rebuild. So we've now put some natural plantings in there in order to be a little more resilient. We have hookups for our food trucks and we move folks in and out of there if there's a storm. We're looking further on. We might do a little bit of resilient building in that area. However, we've yet to determine what that's going to look like. And then there's reduction of infrastructure. So what I'm showing here is an area called Area F or Lot F, and that's the fishing area. And this area took a major beating in Sandy. The road went up about a half a mile and just it goes up a half a mile into the main road. However, probably the last quarter of the mile got undermined during Sandy. And if you look, you can see the last eighth to a quarter there that was completely undermined. Rather than abandon and just remove that area from use, we wanted to continue to use it for the public. So what we did was we went back and we've used a pervious surface of bluestone, and we're trying to ensure that we keep that up. And we also have duned the front of that lot in order to see if we can keep that in place a little bit longer. Final points, and hopefully my timing here works well. I'll be honest with you, the Park Service's lack of preparation. We didn't know that the level would rise and that the power of the storm coming in was gonna leave us as vulnerable as we were with Sandy, and we paid the price. climate change is definitely going to be a driver for how we use and preserve our resources in the future. And the one thing that we did learn, and one takeaway from all of these things, is that we must be able to adapt and overcome moving forward. And that's one of the things that we've benefited from the most. I have to tell you, as we move forward into this decade, one of the things that we look at is the best way to deal with these resources and deal with climate change. And, we're very lucky that we've had partners such as Dr. Psuty and Rutgers University and Jacques Cousteau moving forward to help us along the way. Folks, that's about it for me. If you have any questions, please feel free to ask.
Thank you, Pete. Some really great examples of, going beyond the typical rebuild in kind, in place, and making decisions to be truly more resilient in the future. We don't have any questions in the chat, but if anyone has any, please feel free to put them in there. We can go back for just a minute to Judith's question, since we kind of quickly ran past it. What can we do overall about beach erosion besides continued renourishment? And I think Pete began to speak to that at the beginning of his presentation when he said, we have to decide what we're going to stay with and what we're going to let go. And that is a controversial viewpoint, and certainly more difficult to execute in a developed area than in a park. But Pete, in a 30 seconds or a minute, can you speak to the trouble? Have you had controversy or trouble with some of the decisions to let areas go, and how did you overcome them?
So we went through consultation with the State Historic Preservation Office, and we kind of go through, and we always go through a NEPA process in trying to make the best informed decisions. Obviously we try to be as transparent as possible. I mean, there are certain things that there are certain areas and certain things in regards to some of the older batteries that sat along the shoreline that we've kind of looked, and we've kind of qualified some of those things into either stabilization or ruined zones where we kind of are letting things take their course. But it wasn't until we had to evaluate those things that we actually looked at this. And in 2014 and 2012, as we had gone through the process, Sandy actually exacerbated it. Susanna, your question about the renovation and rental of officers' row properties with climate change. One of the things that we are looking at, and actually Gateway is benefiting from, is this the Great American Outdoors Act. So the area where Officers Row is, we're actually going back and rebuilding that seawall, and we're working with everybody and have input from the Army Corps of Engineers, and we're working to find a correct solution in order to make that seawall work for us, and it's extending up. One of the unique things, the Officers Row property during Sandy, where we saw that input of that influx of water, it never reached the first floor of any of those officer row facilities, any of those older houses. And we actually saw that, and the water was gone within days because of the way that the basements were designed. The Army while they struggled building Officers Row at the turn of the 19th, going into the 20th century, they actually built these things to last. And because of the amount of sand that sits within Fort Hancock and underneath those buildings, the drainage actually worked very well with that. And even we saw the water recede in those buildings very quickly. And the elevations kind of move back and forth along there. However, for the southern half, they actually sit pretty high, and there are facilities that actually didn't have that much of an effect.
Thanks, Pete. Any other questions for Norb or Pete?
We answered everything, huh?
I guess so. And you must have been very clear in your presentations. Well, thank you so much to both our speakers, and thank you to all of our participants and for sticking with us for 2 extra minutes. 2 extra minutes beyond 2 o'clock today. We hope you enjoyed the presentation. I will send out a follow-up email with the presentations and some references, as Norb referenced in his presentation. And if you don't mind just taking 2 minutes, I put a link to an evaluation survey in the chat. I use it for reporting for my coastal training events and to improve trainings in the future, depending on what folks' interests are. So thank you, everybody. Have a great afternoon.
Okay, so long.
Yep. Thank you, everybody.
Thank you.